Hey guys, welcome to the studio. So this is going to be the first episode in a series of videos where I pretty much talk about different 3D modeling principles that can be applied to a variety of different 3D modeling software. Not necessarily the one that I like to use. This one is called plasticity. It's basically 3D modeling for babies. But yeah, I'm going to be going over some different approaches to 3D modeling, specifically towards prop design that I've learned over the years and that can be applied towards a variety of different builds. And hopefully if you guys are able to learn from this, then it'll at least help you reduce your material usage, save you a bit of money, and just streamline your build process as you design and make your own props. So for today's video, I'm going to be going over the use of support rods or alignment rods or wooden dowels or any other material that you're going to use for alignment or internal support that is not 3D printed. And as you can see here, I have Spectre the Unchained's Buzzsaw from the mobile game Arknights. And this is essentially just a fancy staff. Has a very long staff section that has quite a bit of detail work with a separate frame piece. By frame piece, I mean it has a connecting point that is the motor, and then there are two different frames of reference, one being able to rotate on an axis. But anyway, if we move down to the staff section, you can see that in the exterior section of it, you have all this detail work that is 3D printed. It's where your hand goes, it's where you're going to grab it. It has a lot of grip points. However, on the interior, we have this empty hole here. It's basically a negative cylinder that extends throughout the vast majority of the 3D model and throughout the entire staff section, essentially. And what this allows for is you to insert a wooden dowel or a rod or support dowel or whatever, and it offers a whole ton of support. This essentially makes it much stronger. It helps with alignment very much. And yeah, it's just a good idea to do this. Have a negative space for you to put in a wooden dowel and have your wooden dowel planned out. This one in particular is 1 1/8 inch, which is basically 3 centimeters in diameter. And you want to standardize it and have the tolerances already built into the model. That way, as you or whoever else uses their 3D model assembles it and then they use the wooden dowel, they would be able to fit it in very easily. Just use some epoxy to seal it in place, and then it's all good. Offers a ton of support, saves some material as well because you have a lot of empty space. And you don't have to do like this, where you have a 3D printed connecting point or connecting piece, where these would have to just be printed in repeat for each section. This is a terrible idea. In my older models, my older designs, I had these for some of them. Some of my newer ones, I have a few, but those are always printed in a very dense infill. That way they're very rock solid, and you would only use a support or a connecting piece that is 3D printed if you have a very specific connecting hole. So there are very edge cases for that, but for the most part you're going to want to use some a negative space for your internal support rod. That's a good example of a thick internal support rod. However, sometimes you have a lot of big, very chunky pieces, such as this giant piece right here, this neck 3 piece that is split up into 3 chunks, because a lot of times not everyone has a giant 3D printer to print these enormous pieces, and so sometimes you're going to want to chop it up into pieces. And so a good idea is to keep in mind their orientation, how they're going to be printed, how they're going to be assembled, and then just slice them apart and then introduce some internal alignment rods to help with assembly. And you just want to standardize it, get your tolerances in there, and then put them in there. And then that way, when they assemble it, they can very easily buy those cheap thin wooden dowels chop them apart or saw them apart or cut them apart, and then just insert them, use some epoxy, and then that in combination with the wide surface area of the connecting pieces with the epoxy, that allow for a very strong assembly. Right here on the back head one piece, this is an example of making use of a custom insert where one piece fits into another piece and you just don't quite have the space and it doesn't quite make sense to use a support rod. And so right here, this is not a very load bearing piece. It's not going to be all that heavy. So having the connecting pieces be part of this 3D model itself makes sense. That being said, this does break a rule of 3D modeling of mine where the alignment pieces are not straight on connections. As you can see here, the way the exterior edge of this model is like angled inward, that is a bad idea. I did not realize this as I was modeling, and so I had to do some post-processing fixes. That way it would be able to fit in there. Otherwise, you'd have to use like a heat gun, and it's just a bad time. So make sure that all connecting pieces are straight on, not this weird angled shit where you're just gonna have problems after the fact. Now we're gonna look at the head piece of the buzzsaw. Here is a good example of radial connections. Sometimes you have pieces that are circular and they're very big and you're going to need to connect them radially. So here, each of these slices of the pie, they have built-in connection like surfaces, geometry, whatever, where they are able to fit into each other radially. And however, they're still able to connect and fit into each other as straight-on connections. At least this one into the next one, they're straight-on connections. In this case, you'd want to just 3D print like one half of it. So this piece, this piece, this piece, connect them all together, and then do the same with the opposite side. And then the two halves will be able to fit together, and then that way you can very easily assemble it. If I were to redo this, I would instead remove this weird geometry ass motherfucking shit and then just insert those like alignment rods. That way it'll just be a lot simpler and then you don't have to worry about failed prints. All right, here is my latest 3D model. This is Pepe's hammer from Arknights. And this is also a fine example of what is essentially just a staff. Like it's a bit shorter, but if it's like a long linear prop, essentially, I just call it a staff in my mind. Here, this extruded STL is not part of the is not going to be 3D printed. This is essentially a placeholder. This is the wooden dowel itself. And this one in particular is 1 inch in diameter. And so because the character itself, her weapon, has this section being very smooth, not very detailed, there's a pattern that's painted on there, but that can just be done on the wooden dowel itself. Because of that, I just left it as the wooden dowel, very structurally sound, and you can extend it up and into the following pieces. That way it'll be a very strong connection. Here, this crown piece breaks my rule of the angular connection, because each of these crown like pieces here, these little like spiky shits, they enter into this ring top piece at an angle. It breaks my rule because it comes in at an angle. However, because the tops are open-ended, you can very easily print this, line it up into the holes, and then just insert the wooden dowels far in there, and then just kind of like carefully hammer it into the piece, and then it'll be pretty well hidden by the crown itself. Here's another fine example of connecting pieces radially. Here we have this back spiky part of the hammer, and each of these pieces are connected radially using the wooden dowels. These are also 5/16 inch or 8 millimeters in diameter. Here we have one of Bagpipe's gun lances from the game Arknights, and this is essentially just a horizontal staff. And here I also use some thick wooden dowels. And one thing to keep in mind with using alignment rods is your material of choice. I referenced wooden dowels or alignment rods. You can also use aluminum if you want to use like 8 millimeter thick aluminum, for example, if the model calls for it. And by that I mean like you have some connecting pieces that are very thin, not very structurally sound, but they require load bearing on the pieces, and so having something that's much stronger like aluminum that is also very thin would be a good idea to implement into your model. The con for that is that at some conventions, specifically some conventions in California, for example, they do not permit the implementation of metals within your 3D model. I'm sure if you have like a screw here or there, that's fine, but for whatever reason, they don't really like it when you have like a aluminum rod embedded within your prop. It's a whole different topic, but it's a good thing to keep in mind as you're modeling, as you're designing, or if you're going to cosplay the character and go to such cons. It's good to look up the rules ahead of time. In addition to the structural integrity that aluminum rods can provide, because the surface of the aluminum rods are smooth, you can use that for certain applications. For example, if certain parts of your prop, like this other version of Bagpipe's gun lance, certain parts you want it to slide on an aluminum rod as a rail piece, then is also an option to do. Because the surface is very smooth, it'll serve well as a low friction rail piece. But yeah, if there's any other prop design principles that you guys want to see in the future, go ahead and like and subscribe. If you want to support what I'm doing, then go ahead and check out my Patreon page. See ya!